I'm going to talk about using Haxe with the Unreal Engine. If you want, you can follow this link with your computer, or maybe I think mobile devices, just because there will be some code there, and I'm not sure if it will be clear for everybody. So it's okay. So first of all, I think I'd like to say a little of who am I. I fell in love with Haxe some 8 years ago, and it has changed my life to be in contact with it and to be able to read its source code, and I have improved immensely, a lot, as a programmer using it. I have a lot to thank for Haxe for that. And you may know me as the guy behind the Java and C# targets in Haxe. If you haven't tried them, I encourage you to do so. The C# is not still as good as Java, but Java it's working pretty well right now. And both of them, both Java and C#, have JavaLib and NetLib, which allows you to have access to the native libraries, native code, very easily. So, well, and also I am very happy to be an engineer at Proletariat, where I work mostly on the back end, and that gives me an opportunity to do a lot of things that I love at once. Like I can work with Haxe, and I can develop tools for Haxe, and still work with great games. And helping all those come to life is really exciting for me. Okay, so Proletariat is a Boston-based game company. It was founded on, I think, 2012. And it has been crafting multiplayer games ever since. And we have always used Haxe from the start. We used it in the previous game, which is called World Zombination. It's a zombie-themed MMO for mobile. We made it with Unity, and we used Haxe to power both the front end by targeting C# and the back end by targeting Node.js. The game has been very good success since it was launched, and it has been the editor's choice in multiple countries. It was featured as one of the best games of 2016 by the Apple Store. And apart from many features on Android Store and Apple Store, you can see here, oh, it's already playing, yeah. You can see here just how a quick demo of how the gameplay works. So it's basically you can select two factions. You are either the survivors or the zombies, and they both have two wildly different gameplays. But it's been really great too, and it's all done with Haxe and Unity. So, for World Zombination, the first thing is we got to be able to do game logic that was that could work on either technologies. So we have some logic of the game running the same code on both the client and the server, especially so we can not trust the client to give some results, and we do it also in the server. And that allowed us to be able to be free to choose whatever technology best suits us. Not the other way around, like, oh yeah, we are Unity developers or whatever. Yeah, so we ran the same. And we also have used macros to do a lot of transformation in code. For example, we have a macro that transforms. You can write code as if they were synchronous, and it transforms those in asynchronous, which is really useful when you're targeting Node.js. It's also Haxe is statically typed, and it has a great type inferencing engine, so we can be concise and still be safe at the same time. And both on C# and JavaScript, you can easily access the native code. So C#, as I told, has the netlib, which allows you to just use a DLL and get all the definitions. So we use that, for example, for the Unity API. And JS, you can write externs or use untyped. So for Unnex the game, we wanted to make a real-time, fast-paced multiplayer game. And Unreal had recently announced its new revenue system, which you can have access to the source code, and you can use it for free, provided that you pay them a share of your sales. But you have access to the source code. So if you don't know the Unreal Engine, I encourage you also to check it out. It has been chosen by many AAA games, some big names like Street Fighter V, Final Fantasy VII Remake, Batman Arkham Knight, Mortal Kombat 10, and it targets all major platforms, so for desktop like Windows, Linux, Mac, but also consoles, mobile. And it has also VR support, so Oculus Rift and Steam VR. And you have access to the source code, which, believe me, it's helpful. And it has, for us, that was also very important, it has a great out-of-the-box multiplayer support. So you can do, it supports out-of-the-box like replication and physics simulation. So it feels really, it's really easy to do a multiplayer game, real-time game. So I put a demo of Unreal just to show you guys what it's capable of. I'm not going to show the entire thing, but this demo is like from 3 years ago, I think, but I love it. There are some other ones, you can check it out, but I really like, I feel that it's, even though it's 3 years ago, it looks really, really nice. So yeah, you can also afterwards check out the whole thing. So sadly, Unreal Engine is great, but C++ it's the only official programming language. And to be fair, it uses C++ 11, which is immensely better than C++, old C++, and it supports things like anonymous functions, and so it's a little better to work. But yeah, it's C++, and unfortunately, I found this quote when I was researching for ways to integrate with C++, and I found it really describes the situation very well, because Haxe compiles to C++, and Unreal uses C++, so it might be like easy to do that, but actually it was quite hard. They have like two different build systems, and Unreal disables some features that Haxe needs in their compiler options, so you can't include any HXCPP code inside Unreal, and also the C++ glues is very hard to get right regardless of that, because there are a lot of different idioms inside the C++ language, and there are a bunch of exceptions to the rule and things like that that you have to be aware. And also Unreal supports blueprints, which is kind of a visual programming based on states, and it's nice, especially for artists, to do some coding and to do some logic, but more complicated things just get out of hand. So yeah, so Haxe is awesome, and Unreal Engine is awesome, and we didn't want to choose only one. So Unreal.hx was born. So yeah, as I mentioned earlier, I had when I made the Java and C# targets, I had the idea of making them very interoperable with native code. And the idea was to bring that also to the Haxe HXCPP backend. So the idea would be that you wouldn't need C++. You would be able to do everything in Haxe, like extending C++ classes, overriding functions, call super, access protected members, everything, like using templates. So also one thing that is important was, if possible, we wanted to auto-generate the external C++ code, but if we couldn't auto-generate the whole code, it should be as easily as possible for you to write C++ extern. So ideally it would be just like you write an extern and you can use it on Haxe. We also wanted, we were blown from Hugh's talk last year about Cppia, and we wanted to do that. We really wanted to try that to achieve great compilation times. And also we wanted to make it DCE compatible, so that you only have to include the glue that you actually use instead of the whole thing, because the Unreal API is huge. And yeah, did I say supports every feature? That's what we have in mind. And so, wow, why would we want to use Unreal.hx? Yeah, first thing, I think I shouldn't, I don't need to preach for the converted, but anyway, yeah, it uses Haxe, and this is great, this is awesome. Also, it allows you to have garbage collection, which, so all the types that you create, even C++ types that you create with Haxe, they are garbage collected. So you don't have to worry about having to call delete and having a stale reference or something like that. Also, as I will show you, porting from C++ to Haxe is very easy. And because it's so easy also to write externs, you can partition your code between C++ and Haxe very easily. So if you have something that you prefer to leave it on C++, you can, or it's not a all or nothing choice. And you can also allow that we can use Cppia for iteration, and then when you have a final build, you can compile it with HXCPP itself for better performance. And also Haxe support, we support this live metadata, which allows you to do live code reloading using Cppia. And I can say with some confidence that we are the most feature-rich language binding for Unreal at the moment. We support all C++ types because normally the language bindings normally support just the API, which is exposed to blueprints. We have the whole C++ API available for us. And we can do basically everything that you could do with C++. And yeah, both Haxe and Unreal.hx are free open source, and they have a good license. Unreal.hx is on MIT, so it's pretty simple to use and good. And you can also select the code that compiles with HXCPP. Oh, yeah, you can do also, you can reuse your code in other platforms. As, for example, for the game that we are doing, we reused actually a lot of code from our Unity project. So this was pretty fun. And well, talking about our next game, Streamline is the game that is responsible for Unreal.hx. It's a fast-paced third-person multiplayer game which explores the idea of live streaming. So the idea is to aim at broadcasters. So broadcasters can play with their viewers, and the viewers can influence how the game, the environment of the game in real time, and they can vote on things, they can bet, and they can even play some side games while they're watching. And it's been really exciting to work on that. It was built entirely with Unreal.hx, and yeah, we're so this is a little demo that about it. It's still in development, but this was all built in Unreal.hx with Unreal. So the idea is we're watching the view from the streamer, and what he needs to do, he needs to hunt all of the other players and kill them, and the other players have to get the most points possible, and they can run away like from them. They have like boosts and things like that. And the one who gets most points wins. And the viewers, they can change how the environment of the game. So they can, for example, make the floor lava, so nobody can touch the floor, or they can have different gravity settings that they can vote for, or they can also buy them and make them active in-game. Yeah, so it's coming this year for closed beta. Okay, so in the big picture, the Unreal.hx right now it needs Haxe 3.3 and Unreal 4.11. It has some older versions that support like Unreal 4.9 or Haxe 3.2, but the development is Haxe 3.3 right now. And this is, can you see that? Is this clear? Okay. So this is an example of how a project looks like in Unreal. It adds a bunch of it has a bunch of directories already there, like sources where you put your C++ source, and you have binaries and config contents. It's your game contents. And Unreal.hx, when you install it as a plugin. So there is already a plugins directory in Unreal. You put Unreal.hx there. And after you run some bootstrap, it will create that Haxe directory there. So inside this Haxe directory, you have externs, scripts, and static. So the idea is the externs is where all your externs will live. There are actually two externs. There is one on the Unreal.hx project and one inside your Haxe project. And scripts and static is where your game codes will live. So the general workflow is you hit compile in Unreal like you would in a normal C++ project. And then it will take all your externs and run through what we call the extern baking. The idea behind it is that when you, since we wanted to do really simple externs and very straightforward, and Unreal has a lot of externs. I think we have right now about 3,700 externs. So we needed, we wouldn't be able to run this on macros, or your project would take forever to compile. So it still uses macros, but it's a whole different phase that generates other HX files. So you come from your externs definitions, and then it creates some Haxe classes that you can use directly, so it's much faster. So you have then your static compilation, which is the Cppia part, which everything that is on static will always be compiled as Cppia code. And the Cppia compilation, which is the scripts folder. So you can do this, you can run this compilation independently of the whole thing. So you don't have to hit compile on Unreal, because this, for a simple project in Unreal, if, for example, the first compilation of a project takes like 2 minutes to compile, with Haxe, this goes to 3 minutes. But then you can compile it separately with Cppia. So you can have like 0 seconds compilation times. And then after all this, it goes through the C++ compilation of the Unreal part. So how do the externs look? Yeah, can you guys see that? And well, yeah, okay, great. So you basically, when you're defining a new extern, you have to put which include it must use. It could be more than one include if in some special cases you need that. And then you just put this metadata u extern to mark it as really an extern that will go through the extern baker. Extern class, and then you define the extern as you would any normal like JS project. You can use if conditional compilation, and as you can see here, you can use also templated types. And after the baking process, it turns into that. There's a lot of metadata here. You don't have to understand that to be able to use it. It was just a way to be able to get DC to do its job and eliminate any fields that you don't use, so you don't have to generate the code for that. But the idea is also nice to know how the code will look like in both C++ on the header and how the code is working on the Haxe part as well. So you can see here also some examples of what kind of code you can define in Unreal.hx. So you can define, for example, templated types like this T shared pointer, which is actually a shared pointer in Unreal. So it has a reference counting built into it. You can declare C++ enums. You can also use delegates, which is an Unreal thing, but the good thing about these delegates is that you can actually bind a Haxe function to them. So you can use them in Haxe, and it does the right thing, like regarding garbage collection and everything. You can also use method pointers, which are different from the delegates, in which these method pointers are actual C++ method pointers, and we support that. And we also support some operators. We're still working on getting all of them there, but for now you can use them also some operators. Also note that you cannot use any kind of hex type in the externs. So, for example, anonymous types, they have no meaning for C++ as a feature, so you can't use them. Also, you won't be able to use dynamic or neither any hex-only classes like array or string. There is some Unreal side equivalents, and you should use that, like T-array and F-string. And this is how a class definition looks like in the Haxe part. So you can see here, at first we are defining a new delegate. So not only we can declare external delegates, we can actually define new ones. And you can also define your enums, which is C++ enum with some metadata for Unreal. And you can extend other Unreal classes. You can actually do something. Unreal needs some strict naming convention, and you can just not use that in Haxe and just set, oh, the name of this class will be a platformer game mode, and it will work. You can also see that you can use Haxe types when you are extending a class. It's just when you are defining an extern, you can't. But extending classes, you can use Haxe types. You can use Unreal types. This uexpose metadata allows you to expose some variable to the C++ class, the generated C++ class in Unreal. So if you have like some external C++ code that depends on a variable being there, you can expose that to Unreal. There's also, Unreal has some metadata that it uses a header parser to generate some reflection for your C++ classes. So you'll see a lot of those uProperty and uFunction and uClass. Those are all Unreal metadata, and you can define everything in Haxe the same way as you would in Unreal. Yeah, so you can override functions and call super on them. You can okay, yeah. So just one when you're compiling for Cppia, We do support those uProperties and uExpose, but every time you change their signature or you rename them, you have to go through an entire C++ compilation. So you do this compilation once, and then you can iterate on the contents of the function. Okay, so I'm going to do a quick overview of some Unreal types and how they can be used in Haxe, because they are like two different kind of types in Unreal, and they are very different. So in C++, you have basically these UObject types and everything else that sometimes is called structs. Sometimes I refer them as non-UObjects. So those UObjects are the types that have these special reflection metadata, and they are the most feature-complete types in Unreal. They all derive from this base class, which is UObject, and it uses all the reflection from Unreal. So everything that derives from UObject must be a U class. And you can define U functions, U properties. And structs, on the other hand, they can have some reflection metadata, but not all of them have. Actually, most don't. So UObjects use Unreal's own garbage collection system. So this garbage collection works basically with the uProperty metadata. So the a UObject is only considered alive if it's being referenced by a uProperty field on another alive object in Unreal. So it's a very constrained garbage collection system. You have to have this reference somewhere in a member variable with uProperty in it. And structs have manual management memory, so you can do, there are kind of a lot of different kinds of manual management. You can pass them by value, or you can have to delete those, but deleting is not common in the Unreal API. So UObjects they normally use virtual functions, and they are always used as pointers. So because it wouldn't make sense to pass them by value. And structs, on the other hand, they may be accessed by reference or by pointer or by value or by shared pointer. So this is how it looks like. It's just like to get a general idea of both how a C++ UObject looks like and how a C++ struct looks like. A C++ struct is just a C++ struct. You can be a class struct, but it's just like it doesn't extend those UObject types, and it sometimes has a metadata that's called uStruct, but most of them don't have that. So, okay, in Haxe, the UObjects still depend on that uProperty metadata, so you can't have Haxe garbage collection taking over them for some technical issues, because we'd have two garbage collection systems working together, and that doesn't work. So the good part about that is that Haxe types all are already weak pointers. So you can check if they still point to a live object. That's not something you can easily do in C++, meaning that you have to have thought about that before, because there is a special type that allows you to check for that. But if you're using code that has already another the underlying type, you can't know if this object still exists or not until you crash. And structs, the good part is that Haxe, if you created a type, they work through garbage collection nicely. Okay, so UObjects in Haxe, they actually have a wrapper in Haxe, like if you have a class in UObject in C++, you have a wrapper class in Haxe which points to that C++ type. And that's great because you can have cast, you can have interfaces, and it works like normal Haxe code does. For structs, you have a different type that uses abstracts. So we don't need wrappers, and that's really good for performance. But also we lose some runtime type things. So you can't use cast very well. But well, the really good thing about this is just that we can use the external pointer from C++ when it's an external and directly. So you have like very little overhead. And for UObjects, Unreal.hx already knows that the type will be a pointer because all UObjects are pointers. And for structs, you need to specify how the type is accessed on the extern. So you have like, when you're using struct types, you have to define those pref, ppointer, and you can use a lot like const pref or const pointer to const struct. You can use a lot of, but you can't use ppointer of ppointer yet because these types are just annotations. So there, you can see that their implementation in Haxe is actually just like a type def. So this is just so we can know how to generate the right glue code. Haxe code is always, the semantics is the same, so you don't have pass by value in Haxe. So things are still pointers and things can still be null, and they work the same as in Haxe. This is just so that you annotate how the code should be made, how the glue should work. So for future plans, we've contacted Epic, and they've added some pre-built hooks just for us, which is pretty cool. And Epic actually has been, Epic is the company that creates Unreal, that develops Unreal, and they have been very receptive about Unreal.hx, and so they did a way for us to have hooks on the build system, because what we have now is kind of a hack, so we gotta use those. There is also some problems about some externs, because we auto-generate a whole bunch of externs, but sometimes one extern one class in Unreal was defined in one header, but it depends on some other files that it doesn't include itself. So this fails. I have some ideas on how to solve that, but it's still like sometimes you may use an extern which is not working because of that. Also, one thing that we're looking into is optimizing the C++ build speed. There are a bunch of things we could do, like making, like concatenating a lot of C++ glue into a big file. Actually, Unreal already does that to us, but since we know that like this file won't change because it just includes a bunch of glue code, it would make sense to just make this a huge pile of code. And this one also is really exciting. We have talked with Epic folks how to do that. And the idea would be to generate from Cppia directly the U classes, U functions, U properties. So this means that you don't have to go through a whole C++ compilation when you change like a U property type or you add one or anything. You can just use Cppia. Also for like pointer of pointer or some other cases like pointer of basic type, we still need to support that, but it's pretty rare on Unreal code. We haven't actually needed that yet, but it would be nice to have. Also, for now, we only generate the types that are available for blueprints. You can still declare your own externals very easily, as I talked about, but we are looking for ways to like automatically generate everything. Unreal uses Doxygen to be able to generate its documentation, and we want to be able to use that as well so we can get the type info and generate the externals from that. So this would give us the whole API directly. Yeah, also there are a bunch of other minor improvements that like supporting more operators, more functionality. Okay, so I talked a little about Cppia. So it's a virtual machine. It's very compatible with HXCPP. It was created by the same guy. It compiles in a couple of seconds, which is great because, as I told, a normal, not Haxe compilation, like a full compilation in C++ with in a small project takes like 2 minutes and 3 minutes with Haxe. Cppia, as I might be able to show you if we have some time, will compile in 0 seconds, which is pretty cool. Also, it allows the creation of those live functions. So you can have functions that, because Unreal already has hot reloads built into it, like C++ hot reload, so you can hit compile, and it does like reloads every game class, and you can then press play and continue and play the game again with the new code without having to close the editor or something. However, and we already support that for Haxe, and we support that for Cppia as well, so you can just compile Cppia separately without having to compile the whole thing, and just press play and see your changes. But also, if you want to test something while it is playing, we can do that with a special metadata with Cppia. And yeah, as I told you, it still needs a compilation. Okay, so about resources. There is the Unreal C++ documentation. You probably will be able to use any C++ reference, and it's pretty easy to see how this is used in Haxe. Like mostly will be a simple port. There is also a wiki page with all the syntax about Haxe and most of what I talked about and more details about how things are implemented and all this in the wiki page. And I've made for this presentation, I've ported Unreal demo to Haxe. It's still missing some classes, but the big ones are all ported to Haxe right now, so you can access that. And also following Justin's Lua code, Lua repo in GitHub, which I was looking while he was doing that. And I love the thing about doing the comments, and I try to be very specific about what I was doing. Basically, each commit is porting a file, and there's like the C++ initial commit, and then we have like, oh, we just installed Haxe into this. oh, Haxe just installed some directories when I ran Haxe init plugin for the first time. And you can see how it evolves and how actually you can compare C++ and Haxe. And do we have some time for a small demo? Great. Great. Okay. So let me see how I can. Okay. Yeah. Okay. Great. Okay. So here we have it. Okay, so this is that demo project I ported. This is the character movement class, which basically deals, unsurprisingly, with the character movement. And it defines things like acceleration, speed, and how, for example, well, I will show you guys the game, and we can go from there. Okay, so I usually use open the editor on the command line just so I can see better the log messages. There's also a bug that is already an issue in Cppia. So when it has a failure in Cppia code, it prints the error message on the std out. So it's basically good to run it on the console so you can see all the errors. But anyway, while it's opening, let's have a quick look at the code. So we have here just a normal U class that extends this U character movement component. It sets a bunch of different options like max acceleration, maximum walk speed. One thing about the constructor, you have to pass this wrapped because that's how the Haxe code works. So your constructor have to pass on this wrapped type. Okay, so here it is. Well, we had sound too, but let me. Okay, so it's an endless runner. No, it's not endless. It does end very quickly. So it's just a runner. And the first time you play it, it has this tutorial showing you how to work. I'm quite bad at it, so okay, so let's compile it. This is done entirely in Cppia. So if you go to this Haxe folder, it adds a bunch of those HXML files, which is just for being able to compile from the command line or use it on your IDE. You can just do Haxe gen build script, and it compiled. This macro context reused is just that I'm using the Haxe compilation server, and it warns me that everything is fine. So if you just go in times here, it says like, yeah, 0.3 seconds, which is good. Okay, so what we can do here, let's see. This fizz walking function is something that is called every tick, and you can define some physics part. We can add live here. Okay, it got a little more because of the compilation server. Wasn't doing much before, but 1 second is good. Okay, so we have this live function now. So the game still works the same. but let's mess with it. It gets a little janky because of the other screen. We can do max walk speed like 9,000, max acceleration 9,000, and I have to code this quick so we can, and yep, it's there. So yeah, oh, where? Questions?
Just to know, it's really interesting how you use user like action. Is it still like Haxe event, or you have some idle process, special process?
Oh, Unreal has its own system for delegates, events, and these types.
So you don't implement it in Haxe, like just use.
Yeah, we override what C++ does. You can do your own thing inside your Haxe code, but Unreal normally either calls the functions, or you override some functions to be able to get some events, or there are some special events you can use. You can actually bind the Haxe classes, the Haxe functions to them, but you have to you use what Unreal offers, and you can build on that afterwards. But.
Okay, thank you, Cauê.